This novel system enables users to directly interact in 3D by physically touching and manipulating an elastic membrane. The membrane simultaneously provides a surface for interaction and a screen for visualization. The low-friction elastic surface enables haptic feedback to be provided in addition to full 3D motion. 3D multi-touch tracking enables advanced 3D gestures to be performed, creating a more natural and intuitive interface.
An evaluation of the force feedback was carried out through a detailed experiment using a digital force gauge. The force perpendicular to the elastic membrane was measured across a range of different depths and horizontal positions. The first graph illustrates the normal reactive force increases with depth. The second graph shows the map of the forces over the surface of the membrane at a constant depth of 60 mm. The results show that the force also increases close to the edges and corners.
A user interaction experiment was completed to confirm that the haptic feedback significantly increases the accuracy of interaction. Here, a participant is attempting to return to a target depth. The trajectory of their motion was recorded for analysis. The same target depths were also tested without the elastic screen, and the results were compared.
This is a graph of the trajectories for a single target depth for typical users. The interaction without the fabric is shown in red, and with the fabric in blue. The performance of interaction was analyzed using 3 different measures. The accuracy across all users was investigated, and found to be significantly less when the fabric was used. The trajectories were analyzed by counting the number of major crossings, and the results proved users had significantly less crossings with the fabric. Finally, the time taken was assessed. Users were able to return to the target depth significantly faster when provided with haptic feedback.
Several applications were created to demonstrate some of the features eTable is capable of. The system enables advanced manipulation of virtual 3D objects.
In this application, users are able to view and precisely manipulate an MRI scan. The user is able to control which layers of the model are displayed by varying the depths of their 2 fingers simultaneously. The user is also able to use 3D gestures to zoom and scroll around the model whilst changing between the layers. The current layer can be locked in place using a 3rd finger. A 3D grabbing action can be performed to take a screenshot of the current image, and this can be placed in any of the corners. Here, a user is digging a virtual hole. Depending on how deep the user presses into the fabric, the amount of soil displaced is varied. The user is able to recover the hole by lightly brushing the surface of the fabric.